Good afternoon, everyone. It's glad to be here sharing my research and to see if there is any potential collaborations between our group and yours. I'm a faculty member at chemistry department at the College of Science. Here, first of all, I'm giving you an overview of the research projects, ongoing research projects in my research group. We're doing materials at the nanoscale and explore their application in medical diagnostics and food and agriculture. So because of time, so today I'm going to focus only one of the main research direction, that is the application of the nanomaterials in medical diagnostics. And the materials we're interested in is here is a group of metals. So most of them are precious or noble metals. The reason is that they have unique and very interesting physical and chemical properties that enable a lot of amazing applications. And the reason why we're interested in medical diagnostics and food and agriculture use is that in those applications, we only need a very small amount of the material. As we know, the material are way expensive. All right, so I believe I will be missing a lot of details in the talk because I only have 10 minutes for my talk, and I welcome discussions after the meeting, and I hope we will have a collaboration in the future. Okay, so in the medical diagnostics, we have a lot of ongoing projects regarding the property of nanomaterial as the enzyme. So here is an overview of the field. This is about enzyme and also artificial enzyme. So you can see here, there's a lot of ongoing, lot of work regarding enzyme in a lot of fields, especially in biology, materials, and nanotechnology recently. So with the advance of nanoscience and technology, so we can see here over the past several decades, so there are a lot of nanoscale artificial enzyme have been reported. So here, sometimes it's referred to as nanozyme, but anyway, we will call them artificial enzyme made of nano materials. So the nanomaterial have the property of natural enzyme, so that are capable of catalyzing biological reactions. So here, our group is particularly interested in one type of enzyme in particular. So that is peroxidase. So the peroxidase, so here on the left here, I show a most common type of peroxidase called HRP. So which can catalyze the oxidation of a organic compound to an colored compound. So you can see from colorless to colored product, you have a color as the signal generated from the catalytic reaction. So the color signal can be utilized as the detection signal in medical diagnostics. So people like color signal because of its simplicity. So the results can be visualized by naked eyes or can be quantified by an inexpensive spectrometer. So this is why this enzyme is widely used in medical diagnostics. So here are a few examples. So basically, we can detect biomarkers from urine, blood, or saliva, so those liquid samples, or we can do the analysis at the cell level or tissue levels. So the basic principle is that we have the biomarkers, which is the substance to be detected. So that are captured by antibodies, and then the antibody are labeled with an enzyme. So here HRP, so which can generate color signal. So then the intensity of color signal is in direct proportion to the amount of biomarker in the sample. So where you can detect the concentration of disease biomarker with the intensity of a color signal generated by peroxidase. So these are the commercial available diagnostic kits. So I copied online. So there are a lot of similar diagnostic kits for detection in the, so here the platform is known as ELISA. You may probably heard of that. And in the tissue level, or in the regular screening, for example, biopsy, so the similar technology is applied. And we have, advantage of simplicity. So as I just mentioned, the color signal is easy to be visualized or quantified. So the cost of the technology is relatively low. But here, there are some inherent drawback of the technology. So that is primarily about the drawback of the peroxidase. So first is the poor stabilities. So as we know, the enzyme is made of protein. So at a high temperature or acid or basic condition, they will denature and lost their catalytic activity. And most importantly, they have a limited catalytic efficiency. So the catalytic efficiency determines the color signal intensity and therefore determines the detection sensitivity. So which is a critical parameter of a diagnostic kit, because we want to detect a very low concentration of disease biomarker. So especially in the early stage of a disease, so the concentration of biomarker is very low. So we want to know that at the early stage, so especially for cancers, so that we can do some early intervention. So with these, people in the field are using nanoscale particles as an alternative to peroxidase, because as I just mentioned, so nanoparticle has the property of enzyme. So in this case, peroxidase. So this is the reason why I stepped in the field about 6 years ago as I started my independent career. So at the time when I took a look at the catalytic efficiency of the most existing artificial enzyme, and I found that, so here is the chart summarized the catalytic efficiency, so which is the key parameter of the artificial enzyme. So I saw that there's not much improvement of the catalytic efficiency compared to natural enzyme HRP. So, and then I knew that maybe this is because of the lack of precise engineering of the nanoparticles in terms of their morphology, shape, size, and chemical composition. And I did have the experience and expertise in engineering nanoparticles. So that's the fundamental study, as I mentioned in the first few slides. And then, so these are my first study of the nanomaterial. So you can see they are well controlled size and shape. So in the following, I will skip more details because of time. So we were able to enhance the catalytic efficiency by around 400 times. So this is our initial research. And then we applied them to detection of cancer biomarker. So this case is a prostate cancer biomarker. And then later on, building upon this initial study, we did some creative work. For example, we invented an signal amplification technology. And then, so I'm gonna skip this. So because of time, I think I only have 2 minutes. In another platform, so in the previous one I just showed you is in the ELISA platform. And we also did some creative work based on the lateral flow assay or test strip. So the most familiar example might be in the early pregnancy test. So which is easy to use, low cost, but is low sensitivity is a major drawback. And we were able to apply the catalytic nanoparticle to lateral flow assay or test strip, and we were able to significantly enhance the detection sensitivity without compromising its simplicity. And the most recent work, we are exploring more active nanoparticle as the artificial enzyme. So as we know that the nanoparticle catalytic efficiency determines the performance, especially the sensitivity of the eventual diagnostic platform. So here is an example of a strain effect we discovered last year. And this is the most recent work we just published as a cover story of JAX. So here is mostly about our ongoing research. So I will conclude that with another slide. So here I'm seeking for potential collaborations in terms of the following two aspects. So first is the bioapplication of the artificial enzyme. So especially for the specific disease or clinical study, because we do not have the facility and the resources. So if you have this expertise, I welcome collaborations. And the other one is the application of our nanoparticle in other fields. So for example, optics, plasmonics, and the catalysis. So we're also doing some fundamental study in those fields. So if you're interested in that, we may have productive collaborations. And lastly, I thank my group members and the collaborators and the funding support. So currently I have 4 PI projects and I have 1 pending one in the NIH. So this is the one I'm constantly improving the impact score to get funded. So I think it's close to be funded, and now I'm seeking for collaborations with expertise in bio-related research. Thank you so much for your time.